Alright, so Eulerian paths and circuits, what we're looking at is a specific type of path or a specific type of circuit. So the options are you can have an Eulerian path or circuit, or you can have a Hamiltonian path or circuit. You won't like Eulerian, you'll like Hamiltonian, and you'll see why next lesson why you prefer the Hamiltonian. But focusing on the Eulerian, for an Eulerian path or circuit to work, there must be the following rules. For an Eulerian path to exist, there must be 0 or 2 vertices with an odd degree. Okay? So that means when you look at the vertex, what's the degree of that vertex? If it's an odd number, so 1, 3, 5, 7, yada yada yada, you can only have 0 of those or 2 of those in a network for an Eulerian path to exist. If you have one vertex that is odd, but all the rest are even, then you cannot have an Eulerian path, okay? The second bit is for an Eulerian circuit to exist, you cannot have any odd degree vertices, which means if you have a vertex that has a degree of 3 or 5, straight away a circuit is not able. Okay, you cannot have an Eulerian circuit. So that's what we're looking at. But the main thing about Eulerian paths and circuits is that you actually want to use every edge. Eulerian, every edge. Okay? And that's the key phrase you should remember. If you want to find an Eulerian path or an Eulerian circuit, you want to find a path that allows you to use every edge once. Not multiple times, just the one time. Alright, hi. So I'm going to go through this example up here on the board. So we've got a network here, and we're going to decide whether we can find an Eulerian path or an Eulerian circuit for it. So, looking at what we've got. Step 1 says to find the degrees of each vertex. So actually, I might write in black because it is quite faint. So, for part 1, the degree of A, the degree of B, and all the way through. Alright, so you have all your vertices marked out to find the degree. So let's start finding the degree of each one. What's the degree of A? Looking at A, if you just look at how many edges there are, 1, 2, 3, 4. So we're looking at a degree of 4 for A. B, what's the degree of B?
4.
4 again. The degree of C?
2.
The degree of D? 1, 2, 3, 4, 5. The degree of E?
2.
The degree of F? 1, 2, 3, 4, 5. The degree of G? And the degree of H is?
4.
Okay, so we've done the degree of each one. Now, part 2 says, is an Eulerian path possible? Now, for an Eulerian path to be possible, we said it had to have either no or 2 vertices with an odd degree. So, with what we've got here, how many vertices have an odd degree? 2. 5's odd and 5's odd here. So we only have 2 with an odd degree. So yes, we can have a path because we have 2 odd degree vertices, no more, no less. So yes, an Eulerian path is possible. Now we've got the fun job of deciding a path. So we've got to pick a place to start and then go through every edge. So, do you want me to give you a second to have a look at that for yourself to see if you can make an edge?
Well, what do you do? You start at A.
You reckon you start at A? Alright, so let's map it out as we go. We'll see how we go. So, we're going to start here, Will says, and we're going to move the whole way through the network using every edge once.
Oh, okay.
Okay? So, it's going to take us a little while because we're going to use every edge just once. So, starting with A, where would we go?
To B.
So, we'll go A, then we'll go to B, and then where will we go?
C.
C, A, B, C, yep. D, there's nowhere else to go. If you use the road once, you can't use it again.
Oh,
Okay?
okay. Oh, yeah.
So we've got A, B, C, D.
Let's go to H straight out.
H.
No.
No, you can go back to B and you can go back to D, but you can't use the same road twice. So if we've used this one, this one, this one, and this one, where would we go next?
F.
For here, F.
Yeah.
Okay.
And then go back to E. Oh, yeah. And
Then go to
D,
E. Oh, hang on, slow down. Go to E,
And then go back to D, and then use that road back to F.
D, and then go back to F.
Boom.
Okay.
What about D to B? What about D to B?
Oh,
I
miss.
miss.
Miss,
Do
that's
shift
not
A.
one.
Do
Yeah.
shift D and I get to the B line.
Hang on.
Do
We're
it upside
back
down.
at F now.
It's a dead end street.
We're back at F. So if we go up to G, we can go to A, which can go to H, which can go to B, which can go to D, and then we've got a dead end. So that's
That's
all
what I
right.
was saying.
Yeah.
No.
So, what about if we go from we're at D, say we go back to D, should we go up to B then?
Yeah, go back to H.
B, and then
Shut up,
H,
boy. And then go to A.
and then go to A, okay. Well, we're going to go in here. And then we go to F.
And then G.
And then A.
Oh, well done.
Hey man, I was one who chose to start.
Give me a high five, Tootsie.
Okay. I think we used all of them. No, we didn't use all of them.
Yes, we did. We used that one.
We didn't use this one.
No, we did. I remember because I.
Yes, we did.
Yeah, we did. Remember?
No, we didn't.
Yes, we did.
We stopped it because
Yeah,
we
we
went
stopped
from
We went
step
from oh,
A
God,
to
we stopped
B
today.
to C to D
To
to H to F to E to D to B. We bypassed it.
Maybe
Can we start from the beginning?
Maybe the road's under construction.
I'm going to tell you a hint. When you have an odd vertex, you start at an odd vertex. Because you get rid of that one spare one first and you finish with the one
So we should
spare
start
one
at D.
first.
Oh, we should start at B.
Okay, so no, B doesn't have an odd degree.
D.
Oh no, it's not four. No, start at
So you would start at D or F. So if I quickly rub off that section here. Alright. Let's go again. Alright, so where are we starting? D. Okay, let's start with D. And where are we going to go now?
Wait, where we started? Okay.
We're going to start down here from D. Where should we go? So, E. Okay, so we're going to go down here. Then we're going to go where? F.
F.
Back to D. Okay, so we're going to get rid of that early. Yep.
And then C.
So, yep.
D.
B.
D.
Back to D. Okay, so we're going to cancel out all the roads around D. Yep.
And go to H.
Okay, then we go to H.
B.
And then where?
B.
B. Yep.
A.
A. Okay. H again. Oh, so we're being a bit more systematic this time. Yep.
F.
F. Okay.
Oh my god. A. G and then F.
Hey, that was good.
Well done, guys. So what we've done is we've created an Eulerian path.
Fuck yeah.
It takes it takes us a little while to make sure we're finding the right spot to start. But with the hint of starting at the odd degree vertex, it helps you get the path much easier. And the way the class did it just then, it was more systematic. The way you moved, you started here and you sort of covered everything here, and then you went up and covered everything here, and then covered everything here. And that's a very good way to do it because it's quite smooth and you're not going to forget which roads you've used. So that's our Eulerian path. So we should rewrite it in the correct spot as answer. So a path. Now you may not all necessarily come out with the same path, and that's fine, as long as you use every edge once. So we've got D, E, F, D, C, B, D, H, B, A, H, F, A, G, F. Okay, number 3. Is an Eulerian circuit possible? Now, earlier on, I said up here, for an Eulerian circuit to exist, there must be no vertices with an odd degree. Now, we have 2 vertices with an odd degree. So, we cannot create a circuit because we have an odd degree vertex there. Does that make sense? So you just made your question much easier because you don't have to work it out. So you just say, no, there is not an Eulerian circuit. Why? Can't spell. Due to D and F having odd degrees. And that's it. And that's it, and you're done. That's how complicated Eulerian circuits and paths get. The worst bit is trying to find a path or a circuit and making sure that you've covered every edge once and not overlapping it. Alright, ladies and gents, so you're going to be able to start.
Say after possible and comma. Up top, no, at number 2, yeah.
Oh, if so, state a path. Alright, so what we're going to do is I'm going to set some questions on the board for you guys to start working on.